this is like a general like developer type of conference, not specifically Kubernetes. Who here has actually used Kubernetes thus far? So most everyone. Okay, cool. So awesome. All right. So yeah, I'm Tiffany Jernigan. I am a developer advocate at VMware. If you're not sure what a developer advocate is, there's a bunch of us here from different companies, and you can ask any one of us, and the answer might be different. But you feel free to ask me later. So yeah, I have my Twitter up there, and since now there's like a million different social media things like Blue Sky and Mastodon and all that, I have a link tree because I got lazy. So if you use any of those things, you can find me on there. Okay, so I'm just gonna dive kind of right in. So like most of the talk that I have is mostly visualizations versus a bunch of bullet points. So this talk was actually given with my co-speaker and good friend Matthias in KubeCon. This time I get to do it all by myself. But yeah, so, and that's his Twitter handle down there. But yeah, so basically overall, when dealing with like your applications or what you're having other people use, it's basically ends up being about like the users and the clients, which are like the lovely little cute stick figures over here in the corner. So basically the main goal that we have is we want to make these people happy. So in order to be able to do that, we need our services and our system to be as good as stable as possible. So like the system is like the things that we're specifically running, for instance, like our containers and running things on Kubernetes. And obviously, the production readiness is a lot broader than just Kubernetes, but this talk is focused basically on Kubernetes and like the cloud native ecosystem. So yeah, that gets us to like what is prod readiness. So I don't know that there's actually some like official definition out there. It seems like depending on who you ask, it can be a little bit different for that definition, but I'm going to try going and summarizing it kind of at a high level. So basically, like one of the ways that we decided to like describe it is having it where the state of a system which is fully prepared and capable of running production workloads, and it provides the level of service and performance required by its users. So that kind of goes back to the slide just a little bit, like 2 slides ago, that has the users, the service, and the system. And again, this definition is not bound or scoped specifically to Kubernetes. It's a lot more than that. So if we want to go into things in a little bit more detail, and this is one of 2 slides on this deck where there's a bunch of bullet points. So I'm not going to go through every single thing that is on here because it's kind of a lot. But so like one of the essential things, for instance, is the second bullet there of making sure that things are reliable, that they're stable, and that they're secure. And basically that the things that you have running or how things are working end up going as you would have expected. And if they have to be ready for things that like may not be how you expected, and that your system can do something based on whatever ends up happening, whether it's a good thing, a bad thing, expected or not. And basically you want to make sure that it can adapt well to things that change. And then with having all that kind of stuff, you also want to be able to do things with being able to monitor and observe whatever you have running, because then it makes it a lot easier to see, hey, are things working as I expect them to? And if not, how do I figure out what is specifically wrong with what's happening here? Another thing which I feel like a lot of the times it's like, hey, I'm going to write a bunch of code, I'm going to make sure all this stuff works, okay, cool, maybe, hopefully not just maybe, but maybe you have your testing there. But then if you're trying to get other people to be able to use what you have, you need to have some form of documentation. And the better the documentation, the more you're going to have other people trying to use your things. So basically, now I'm going to go into like what like vanilla Kubernetes provides. So like again, like prod readiness is a thing that exists without Kubernetes itself, but this is going to be now going down the realm of Kubernetes itself and cloud native. So since most everyone raised your hand here, this is going to be a very familiar slide. So basically, at like a super high level, Kubernetes basically runs and manages your container workloads. So like if you want to have, for instance, I have this Nginx application, or I have my specific web page, or whatever it is, and you're like, hey, I want to run a bunch of copies of it for high availability, or like, how do I go about handling this? So that's basically where Kubernetes ended up coming along. For anyone who is not super familiar with Kubernetes, there's a QR code up there that goes to a blog that I wrote of like getting started with Kubernetes. There's may or may not, depending on how, there's a talk related to it, and I don't remember if it's attached to that, but it should be easy enough to find, but that can be pretty helpful if you're newer to Kubernetes. So in this lovely diagram here with, again, our cute little stick figures, especially, I like the one with the mustache especially, but you can see a bunch of users, you can see a bunch of pods, and if you're unfamiliar with pods, that's basically where your containers end up running. And Kubernetes has some like basic things built in, such as with those little scrolls, that's implying logging, so you can use kubectl logs, and if you have access to, say, the control plane where you can SSH in, or some other way of getting to it, you can have access to kubelet logs as well. So kind of to like summarize that a bit. So Kubernetes is a distributed platform for running, connecting, and logging your containerized workloads. It does all of these things to a certain extent, and depending on which thing is listed there, the extent of that is different. Okay. And there may be a little bit of internet issues because, for instance, I had to look up here to see if this was showed anything because on my screen it's blank. So yeah, basically Kubernetes is pretty flexible at infrastructure level. So when you're thinking of nodes, so like independent of dealing with what I'm running, there's the ability to do scaling with the, which is down, you can see at the bottom, it's being able to scale your nodes up. So if you're like, hey, I created a Kubernetes cluster and right now I just need to have one node, that's great. But then later on you decide, hey, I need to have 5. You don't have to worry about being like, oh, I need to create a whole new cluster, this is a problem. You can actually relatively easily scale up, especially if you're using something like a managed Kubernetes offering. And with that, you can also, of course, be able to scale down. And one of the great things here is that you can do this scaling as long as you don't like completely get rid of all of your nodes. This isn't going to just go and interrupt the behavior of your apps so long as you have enough like memory and CPU usage for whatever you're running. So you can be like, hey, I'm going to scale up or scale down and not have to stop everything that's running, and then all your customers are angry. So in addition to that, you can also be able to scale and have things where you're trying to be like highly available on a workload level. So you can kind of see like the different things there. You can be like, hey, I want to have 5 copies of whatever pod it is, like just like however many you want. You can do things also such as graceful migration between different versions of your application as well. And then there's also things like fault tolerance. So this is very difficult because I can't actually, I'm going to keep looking up here because I can't actually see my slides over here at all. Yeah, so like for instance, if you're dealing with upgrading, if you're going from one version of your application to another, you can do it where you have like rolling updates and you don't have to worry about like 0 downtime. There is auto load balancing between, like say if you have 3 different copies of your application and you have a service, it will do automatic load balancing between those there as well. And I can't fully read that. Yeah, auto restarts. So for instance, like as long as you're not using just a generic pod, if you're using a generic pod, once that dies, well, it's never coming back, and that's unfortunate. So you want something such as like a deployment or a daemon set or one of the other types of resources that checks to see, hey, do I have fewer pods running than I actually want to have? And then based on that, it will start those up again. Okay, so like as a summary of just like core of Kubernetes, like some of the things are like high availability and resilience of your workloads. Like making sure that your application isn't just going to stop working because it will make sure that things are still running. There's things that deal fault tolerance. There's the elasticity of both your infrastructure and as well as with your workloads. And then there's also extensibility as well. So hopefully at this point we're all kind of like at a similar spot of what's happening here. So like say right now if I were to be like, hey, I am going to create some cluster using Minikube or kubeadm or wherever else I decide to go and create my cluster, the question then is like how far away am I from actually being production ready at this point? So to like kind of simplify it, there are a few like areas that I'm going to specifically focus on for this. So there's security, workloads, network, infrastructure, and observability. And some of these actually kind of overlap with each other. Like you could have things that are specifically security and networking, et cetera, that kind of work together. So yeah, if you're running Kubernetes, basically there's a few things that you have to do. For instance, you have to actually provide the underlying hardware that it requires. If you don't have the hardware, then like nothing can be run. It's just like the concept of saying serverless, but that doesn't mean there's no servers, for instance. These VMs could end up being things like on the cloud, it could be bare metal, you could be running on a Raspberry Pi if you wanted to. You end up needing things like such as having backups, whether that is for like your specific workloads or being able to back up like your cluster for if something happens, something goes down, or somebody did something and all of a sudden everything is failing. Like ability to go back in time a bit to go like fix the state without spending maybe like hundreds of thousands of hours or whatever it might be to get things to be in a good place. You might have something like some sort of like database service or some sort of legacy service that you can't directly run in Kubernetes, but you need to be able to provide that to your cluster in some way. Okay, so we have like, this is kind of like a little overview of the different things there. So like we have like the underlying hardware that you need. There's like, for storage, for instance, the Kubernetes API has API objects for storage. For example, there's things like persistent volume claims and persistent volumes. Like they'll work pretty much the same for any cluster that you end up using, but like if you want to attach some sort of like external storage, for instance, running maybe like on some cloud provider that is not specifically part of one of the things you're trying to set up with Kubernetes, then you need to be able to provide this and tell Kubernetes how to be able to consume that in a way. There's things with backing up your infrastructure and your workloads, which I was just mentioning. And then there's things of like being able to connect to things outside of Kubernetes, such as like databases, for instance, and just like making sure that whatever you're running is accessible to your workloads. Okay, so this brings us over to networking. So like if you're just initially running your application on your cluster, if you are just using like the type of cluster IP for your service, or say you don't even have a service. Right now, your application that's running, no one in the outside world can see it. It's just you, which if you're just playing around, that's fine. But if you're trying to do something that's in production, you're trying to get it where people are actually going to whatever your website or whatever it is, you need them to be able to actually get access to that. So that's where you need to have Ingress. And Ingress is a Kubernetes API object by default. However, it doesn't automatically include Ingress controller. So you need to decide, hey, there's multiple out there. What kind of Ingress controller do I want to end up using? And if that, for whatever reason, doesn't give you like the level of granularity that you actually want, there's this relatively new thing called the Gateway API. I don't know much about it, so if you ask me about it, I'll have to tell you later. And then you could also do like your own sort of like custom implementation, such as doing some exposing like load balancers, et cetera. Basically, like what it comes down to is there is not like one correct way of going about this. It kind of depends on what you specifically need, but there's different options. Okay, so by default, I was mentioning that there is like some level of load balancing. So for instance, if we look at the two pods up there, ignoring the percentages for now, if you have like your service and it does load balancing, it would be about 50-50 between the two pods since you have two of them. But it's not necessarily always going to be like that. Like if you want it to be like 66-33, then you actually need something perhaps like a service mesh, for instance. Or being able to, if you look on the right side over there, being able to do encryption of traffic between the different things that you're running, or like basically like the percentage routing and the encryption, those are things that you can't specifically do by default in Kubernetes. And so that's where, again, basically you could use something like a service mesh. So then like a few other things are there's network policies. So you can do that for like isolating traffic. Like the concept of network policies exists in Kubernetes by default, but you have to go and create them. And then there's the encryption between the workloads, and then there's like advanced routing, such as with like HTTP headers, for instance. And overall, like, this is 30 minutes. This is only brushing very high level on all of these different things to give you an idea of things that you should look into if you are trying to go to production. So after we go from networking, now this is observability. It's kind of like how Kubernetes is K8s. A lot of people, I guess, started doing it like that in the same vein. But so as I mentioned earlier, there is like basic levels of logging where you have kubectl logs, there's kubelet logs, and then you can do things with like metrics to a like little extent if you end up setting up some sort of metric server, which some managed clusters have by default, but not all of them. But that alone is not really enough. So if you want to be able to like expose your workloads, you kind of need to know what is actually going on. Kubernetes itself doesn't have like a full-on monitoring stack. You need basically somewhere where you can go and persist and like visualize your data. So a lot of people end up using things like Prometheus for metrics and then being able to view that in Grafana, or do things with tracing with like Jaeger, for instance. So then we have security. So one of the things that you could do is you could have some sort of like namespace isolation. So say you have some person in your company and maybe they're just learning how to do something with Kubernetes. You could have an entirely new namespace just for them, where they could even be the admin of that namespace and do whatever they want in there and it not affect anything else from within the cluster, which is super important if you end up having them for some reason being on the same cluster as your prod. And you want to make sure they can't just do that. I would say that you shouldn't let any one person have access to be able to, like with kubectl, to be able to do something with prod. It should actually be some sort of CI/CD system instead, because then it ends up being super repeatable and you don't have to worry about, oh, who did this? Did someone like mess something up, whether it's intentional or on purpose? Then there's also RBAC and service accounts. So RBAC is role-based access control. So you can do things like, hey, for this specific service account, for whichever user person this is, you have the ability to just view what's in a cluster, or you can just view what's in a specific namespace, or you can create pods, but only in this one namespace, or only in this one cluster, and just like define how you want things to be for a specific person and just narrow it down. Basically, don't give cluster admin access to everyone. It's like basically like giving root access to your computer, which I assume most people here would be like, no, I would never do that. So please don't do that. And then there's also pod security standards and pod security admission to do more things with that whole aspect as well. The QR code in the corner there, assuming I did things right. I did a talk on getting started with cloud native security. There's a blog as well, which I should have put that link to. But if you look up anywhere on the internet, cloud native security for the rest of us, there's a talk and there's a blog. And basically, it's on the viewpoint of, I don't know anything about security. I should learn about security and then write something. Hopefully, that'll be useful for other people who are learning. So we've looked a bunch into like general things with like networking. We've looked at security, observability, et cetera. But like we haven't actually fully looked into things like, what about the workloads themselves? Because yes, you need the whole environment. There's a bunch of different things that you need to set up, but you also have to worry about the specific workloads that you have. Like in the end, like the users of your application, they don't actually care where things are being run. They don't really care about what language you're using unless they are just like, oh my gosh, Java is the best language ever and you can't use anything else. Then maybe those people care, but that's hopefully not everyone. But basically in the end, like the production readiness of your whole system is like a combination of like the runtime and also the workloads that you're running on them. Like if you harden your cluster in like the best possible way, but you are still failing with your workloads, then that's not good. So how do we go about like covering some of those aspects? Like how do we ensure that like things are stable? How do we ensure they're secure? How do we ensure that they're observable? So if we look over on the left side here, there's more of our cute little stick figures. And so those are our developers. And then over on the right side, those little stick figures, those are the consumers, or basically whoever is using it. So like the question is like, how do we get from there over to the side over there? Like we want to basically have some sort of automation where things can be done in a repeatable way without having a bunch of manual steps. There's a lot less room for error. You can make sure that you keep doing the same thing. You could have some sort of like 2 versions of building stuff with your CI/CD system, and you can see, hey, I ran this twice, and look, I got the exact same binary at the end, therefore things are working right. And then there's basically a bunch of different tools that are out there, both just like in the specific Kubernetes realm, but also in the cloud native space that can help like make this whole path be repeatable. Like there's things all the way along, like you start with your code, you have to build your code, you need to make sure you have testing. When you're dealing with Kubernetes, you have to be able to containerize it, and then you have to push it to some sort of registry and then deploy it. So this needs to be able to consistently happen and not take a ton of like manual time, ideally not a ton of time in general. So there's also some other things that come along here as well. So there are some tools that can help make your life a little bit easier. Who here thinks that there's a lot of YAML involved with Kubernetes? All right, yeah. Like Josh Long jokes about Kubernetes being like his favorite YAML database. But basically there are ways to make that less terrible in the sense of basically like you can end up having tools like kustomize. There's different tools in the Carvel tool suite. There's Helm for being able to have it where you end up having your, whatever you have running, like here's your YAML, instead of being like, here, I'm gonna make a bunch of copies of my YAML. Instead, I'm going to replace the different values in there, and then now you have fewer like different YAML files for doing that. Then there's also things with like GitOps, which is having Flux and Argo. And then there are cute little locks over there. Then that part there is for supply chain security. So basically, with supply chain security, you need to actually work that whole concept of hardening. You need to worry about going all the way along the entire path of security for all of these things. For instance, like for checking for vulnerabilities or CVEs on your images. And apparently, I have less time than I thought my clock here tells me, because mine says 10 minutes, but I got a 5, so I guess okay, so it's 10, all right. Okay, so, yeah, again, back to where I can't see the slides, so internet. Yeah, so basically, in summary, like, there's a reason this whole thing looks chaotic. Like, this is basically a summary of all the different things that I've just gone into. Like, it's not just chaotic, like, on this slide, it literally is, in a way, kind of chaotic. There are so many things that you actually have to go and worry about when you're trying to go from, here's my Kubernetes cluster, to, like, actually being production ready. Like, it doesn't include every single thing that we need. Part of it is because there's so many different opinions out there, and something may work for someone, it may not work for another, and there's only so much you can shove into, like, one specific project and ecosystem. So back to this slide, to basically simplify it, like these are the like problem areas that, or at least some of them, there's going to be other things in general too. But like these are the main ones that Matthias and I came across when we were looking through it, of the things that you have to deal with. So again, that's security, workloads, network, infrastructure, and observability. So this here is like trying to grab like at least a subset of the things that have been gone through into a like checklist for things of, hey, maybe this is something I should look into, and is broken down into those different categories. So yeah, this is the, who here has seen this before? Okay, so there's a reason you can't read anything. This is a CNCF landscape. There is a lot of stuff there. It's broken down into different sections. Some of those may be things that are observability. Some of those things may be security, et cetera. There's just so many different projects out there. Some of them are in different stages. So maybe they are graduated, maybe they're incubating, sandbox, et cetera, or just in the ecosystem. So there's no possible way for me to be like, one, first off, I can't tell you what they all are. I don't have, my brain doesn't like pick up knowledge that easily. And two, there's just so many things out there that you have to decide like what is specifically important to you. Maybe it's something that maybe you care, so the first thing that you care about is security. Which one of those things do you need? Do you need something to specifically deal with certificates? There's just so much stuff out there. But Matthias and I tried like grabbing a few things in each of these different categories of things that we either that are either graduated or in some sort of state like that, or things that we had specifically worked with before. So these are just suggestions. It does not mean that they are the best ones or the only correct ones at all. So just things to look into. So for infrastructure, there's things like cluster API, which you can use for going and creating Kubernetes clusters. There's Valero, which is used for backing up the workloads on your cluster, and it will also back up persistent volumes, which is pretty cool. And all of this stuff is open source as well. So those two are specifically focused with Kubernetes, and then there's things that are more broad. So there's things like Terraform, there's Pulumi, there's Crossplay, and basically like infrastructure as code. And then you can use that to go and create your Kubernetes infrastructure if you want. So networking. So we have things like Istio, we have Linkerd, and so those things fall into the realm of like service mesh, which I very briefly touched upon. And then there is also eBPF, which is also in a similar vein, but I guess who here has heard of service mesh or like knows anything about it? All right, eBPF. Okay. So if you want to learn a little bit more about those things, Matthias and I did a talk. You probably just look up my name and type eBPF. There's a talk that involves stuff with service mesh and eBPF that he created, and he let me speak along with, so that's cool. But yeah, it goes into some of those things. So like just as a high level, like with your service mesh, you end up having a proxy running on every single one of your pod to get more information. Whereas for eBPF, it runs on each node instead. And you can do things with, like, it helps with like networking, observability, et cetera. So there's Cilium, which is basically based on eBPF. And so that interacts with the network, again, like on the node level. And it can do similar things with service mesh. It can do observability, et cetera. There's Entrea, which implements CNI, which is the container network interface, I believe. And also like the Kubernetes network policy, so that ends up providing like network connectivity and security for your pod workloads. So then now we have observability. So there's things with like Prometheus. You can get a bunch of different metrics. You can put those metrics into Grafana to be able to have some different charts and visualization, because sometimes like just having the numbers and going through that can be kind of complicated, especially over an extended period of time. Versus if you have Grafana, you can be like, oh, hey, things were going great, and oh no, suddenly this stopped working at this point in time, and you can see that. There's Jaeger for distributed tracing. There's OpenTelemetry. So that's like basically a standard like observability integration layer for like logs, metrics, and traces. There's Kiali, which is for observability on service meshes in particular, and then FluentD with logging. So then there's security. So for OPA and Kyverno, those are policy-based control. There's Cert Manager for, well, managing certificates. It's kind of nice when names sometimes actually tell you what they do. There's Tough, which is a framework for securing software update systems. There's Keycloak, which is dealing with identity and access management, or IAM. There's Spiffy and Spire. And there's also Toto, and I'm going to scoot a little faster because I'm running out of time. So yeah, there also are things specifically with workloads. Some of these came up a little bit earlier, but like, so for instance, you have Helm to deal with packaging, you have build packs, so instead of having a Docker file, you can be like, here's my code, and it will be able to create a container image from that. There's Flux and Argo, so that's for like continuous delivery, which is part of your CI/CD pipeline. So basically the question is, now what? So this is a quote from Kelsey Hightower in like 2019, but basically it's saying that there's all these things that you have and you need to keep all of this in sync. So this is like a huge like diagram here, but basically like people used to use things like ASS, CASS, and PAS, etc. And like this is kind of split into 3 different things for how things are with like the different levels of management with Kubernetes. And so on the left is basically, hey, I'm managing all this stuff myself. In the middle, there's all the green stuff is things that some sort of provider manages. And so it's just kind of like determining like what level of things do you want them to be like managing. And the more you manage, the more you have to be responsible for having those people and paying them to do those specific things. Tanzu Kubernetes Grid has a opinionated version of using a bunch of different tools, which you saw some of those for dealing with some of these things. There's a decision you'll have to make, for instance, of deciding between, hey, do I want to run in the cloud or do I want to go and run on-prem? And so here's basically a quick decision tree for that, which I guess I also talked too slow earlier in getting into. But like, for instance, you have a lot of bare metal that you want on-prem, and if you have sensitive apps, if your country has a provide cloud, then you can use the cloud. Otherwise, you'll also have to go on your own. Then there's the concept of, do I use managed or self-hosted? And there's just a whole bunch of decisions that you're going to have to make on that as well. So the best way is to basically, in my opinion, is to not worry about it and have someone run things for you. So like in the end, basically, there isn't really like a right or wrong answer. Like the goal of this is to show you basically there's a lot more to it than just here's my applications, here's my YAML, and okay, that's great. Like you'll have to decide what methods that you want to like do, where you want to spend your money, your resources, your time, etc. Maybe you want to maintain it yourself and then invest your time and money into that. Or maybe you want someone else to worry about it and you can just worry about your applications. Like there's no one, like this is the answer for every single person and that's how it is. Like, but my suggestion is to go with the highest abstraction available. Like try to not do something that someone else has already solved, and this gives you more time to work on your applications instead. This is a slide that shows, I guess now you can actually, if you know Matthias or not, but like that's his Twitter, and that's a way if you want to contact either of us afterward. And yeah, so thanks.